Section 4.5, Example 2, Compound Interest. Suppose we want to invest $10,000 and hope to have $15,000 in 8 years. So our principal is $10,000, our amount is $15,000, our time is 8 years. Interest rate compounded annually. So that would mean that not T, but N equals 1 time per year compounding. Must we seek to achieve this desired result? Okay, having n equal 1 kind of simplifies our equation by quite a bit. And of course, what are we trying to solve for? We are trying to find the rate. So we are finding R. That's new, right? Okay, here's our formula. So we have our amount that we're trying to get is 15,000. And we have our principal that we're investing is 10,000. And we are compounding annually. So that's a 1. And then that's going to be in 8 years. So 1 times 8. See how nice it is when it's annual? It's just, that 1 is just nice. So this will not be terribly ugly. Okay, isolation first. So, sounds like a pandemic term. We have a virus, so we're going to isolate the exponential because it's positive. Just kidding. I'm silly, right? I had nothing to be but silly in an empty classroom talking to you all. Okay, so now that I have all these 1s everywhere, I'm just going to ignore the 1s because they're just making it ugly when it's really this simple. Yes? Okay, so now we can do log both sides, or we keep doing log base 10. Let's do natural log just for the heck of it. It doesn't really matter. They're both on our calculator. It doesn't matter which one we use. And then after we do the log of this side, then we're going to move that 8 to the front, right? So I'm just going to go ahead and do that now. Well, this is interesting because the R is inside of our logarithm. How is this going to turn out? Okay, well, it's going to turn out fine because natural log of 1.5 is a number, right? And we're going to divide that by 8, and then we're going to have a number that's divided by 8. So it's a new number. And then we're going to be able to change this to exponential form using base e. Maybe I should have just gone with log base 10. I could always change it and do log base 10 right now. It really doesn't matter what your base is. Really, it really doesn't. Okay, so I'm going to go ahead and divide my 8 from both sides. So divide the 8 there, divide the 8 there, 2. So now, this is just a number. Just don't freak out about it. It's a number. Your calculator's going to give you that number. So right now, our important thing here is getting rid of this logarithm. And we can get rid of the logarithm by changing this back to an exponential. I wonder if there was something we could have done here instead of doing this logarithm to begin with. Oh, look at that. Totally was. So I'm on this wavelength of using a logarithm. How many of you would like me to finish the wavelength of using a logarithm, where a logarithm is an exponent? The base of the logarithm I chose is e, so base e, exponent natural log 1.5 divided by 8. And then that's going to equal 1 plus r. So then r is just going to be taking this in the calculator and subtracting 1 from it. Yeah, I made this much more complicated than I needed to because I was in the frame of mind, oh, it's an exponential, we need to use a logarithm, when in fact, we didn't need to. It's an exponent without a variable in the exponent. When it's an exponent without a variable in the exponent, this is just a root problem. Okay, so we didn't need to do all this. Ta-ta-da. Don't you love that my videos are just so real with all of my mistakes? But then I feel like that's good because if you make similar mistakes, maybe you don't feel so bad. And you can see the process of there's more than one way to do this problem, even though one way might be easier than something else. So at this point, to get rid of our 8th power, we don't need to use a logarithm. All we need is an 8th root. So we want the 8th root of 1.5 is going to equal the 8th root of 1 plus r to the 8th power, which cancels our 8th root, right? Boop, boop. So now r is simply going to be well, this thing equals 1 plus r. So r is simply going to be this 8th root thing of 1.5 minus 1. Now, most scientific calculators, well, pretty much all scientific calculators have ways that you can do different roots. Another way you can do a root by using an exponent is to actually take it to a fraction. Excuse me, like the 1/8 power instead of using a root. So either way, figure out how your calculator will do an 8th root, or just use a fraction, power 1/8. Okay, so let's go ahead and put this on our calculator. Maybe I'll show you both ways of doing this. Let's clear my screen. Oh, I don't remember how to clear my screen, so I won't worry about it. Okay, so we're going to type in 1.5 to the 1/8 power. Okay, so that's 1.0519. So now remember, I'm taking that number and I'm subtracting 1 from it, which leaves me with 0.05199. Okay, so 0.5199. So I got 1.05, was it 199? And I subtract 1 from that, so that gives me 0.05199. And then I can change that back to a percent if I want. So that's like a 5.2% interest rate that would yield those results. Let's go back to the calculator now and see if we can figure out how to do the 8th instead. I mean, not the 8th, but the 8th root instead of the 1/8 power. Just for fun. And I know you're not necessarily using these kind of calculators because they are illegal on your tests in this class. But just to kind of give you a suggestion on how it might work. I need my screen to be a little bit bigger though so I can see this calculator. See if I can see any options for a different root. Do I have a square root here handy anywhere? Oh, there it is right there. Oh, there it is. So, just see that little thing? This is what I wanted to bring to your attention. Maybe you can see this. It's just this little teeny thing in blue. It says n root x. So I have to hit control to get to that. So there it is, and that's where I can type my 8 in there and my 1.5 in here. So scientific and graphing calculators all have like an option like that. So notice how 1.5 to the 1/8 power and the 8th root of 1.5, they both give me the same answer, which results in my same conclusion.